there's one other thing that I neglected to cover yesterday. It relates back to the Pythagorean theorem. I want to go over it. I won't say real quick, but I do want to just make sure that you're exposed to it. And that's basically, we can use the Pythagorean theorem to determine whether a triangle is acute or obtuse. Okay? And basically, we have two potential situations. We have two different looking triangles. All will look like this. They don't have to look like this, by the way. A, C, B. A, C, B. Basically, we have, when we use the Pythagorean theorem, we know that a squared plus b squared equals c squared. Okay? Now, we have two other possibilities. One is that c squared is greater than a squared plus b squared. And then, or that c squared is less than a squared plus b squared. Again, if a squared plus b squared equals c squared, we know I have a right triangle. But if a squared plus b squared is less than c squared, that means that your triangle is obtuse. In other words, if this angle is going to be greater than 90 degrees. On the other hand, if you have a squared and b squared, and it's greater than c squared, or in other words, if c squared is less, then you have an acute triangle. Okay, and what you're going to be asked to do is you're going to be given the three sides of a triangle, and you're going to be asked, yesterday we just asked the question, is it a right triangle? And in today's bell work, we asked, is it a right triangle? So now, let's go back to the bell work, and let's see whether it's we know it's not a right triangle, let's see whether it's an obtuse triangle or an acute triangle. So let's go back to the bell work, and what do we see? So we want to know 16, 48, and 50. So we do the exact same thing that we did. Now we look at our answer, and we saw that what? We saw that a squared plus b squared is what? Greater than 2,500 or less than 2,500? It's greater than 2,500. So since the square of the side of the hypotenuse, the square of the hypotenuse is greater, then my triangle is obtuse. Now, of course, we don't know what the angles are. I can't tell you that the angle is, whether it's a 91 degree angle, or a 111 degree angle, or a 159 degree angle. So it's not going to tell you the measure of the angles. It is just going to tell you, is the triangle obtuse, or is the triangle acute? And of course, if it's a squared plus b squared equals c squared, we know it is a right triangle. Sir? Remember, the Pythagorean theorem only works for right triangles. All right. So I just wanted to go over that quickly. And now we're moving on to today's lesson, which deals with Today we're going to talk about two different kinds of special right triangles. Okay? Now, when we talk about this, these refer to the measures of the angles. So these are special right triangles where my two legs, the angles are 45 degrees, and then we have the hypotenuse, which is 90, the right angle, which is 90. And then we have triangle where it's a 30, 60, 90 degree triangle. And what's nice about this is there's a special relationship between the sides that lets us calculate length very easily. Okay? And then these triangles are in a special ratio. Okay, so if I have a 45, 45, 90 degree right triangle, what kind of triangle is that besides a right triangle? Jonathan? It's an isosceles triangle. And what does that mean about the length of these two sides? They are the same. Okay? So whatever the value of this value is going to be the same. Yes?
Does that mean all right triangles are isosceles?
No. I'm going to go over one where it's not. So, whatever the length of the other sides of the triangle, and we're going to call them S, the length of the hypotenuse is the length of that side times the square root of 2. Okay? Again, remember, these are the same because it's an isosceles triangle. Whatever the length of the sides of the legs, the length of the hypotenuse is whatever that number is times the square root of 2. So if I give you a triangle, and I tell you that the length of the side is 9, what's the length of the hypotenuse? I don't want a numerical number, I want a square root. The length of the triangle is 9, what's the length of the hypotenuse? You don't need a calculator.
Square root of 9.
No. No.
9 square root
Of?
of 3.
No.
9
2.
9 square root of 9.
If the length of the side is 9, what's the length of the hypotenuse? Riley?
9 square root of 2.
9 square root of 2. That is correct. Okay? Okay. We'll come back to this. All right, now, so finding the hypotenuse is easy. What if, though, I give you the length of the hypotenuse and I want to know the length of the side? Not so easy. So here's my triangle. I'm told that the length of the hypotenuse is 6. And remember, these are 45 degree angles, so we're dealing with a 45, 45, 90 right triangle. So basically, the general equation says that the hypotenuse is equal to the length of the leg of the triangle, right, times the square root of 2. This is the general equation. And you can use this equation whether they tell you the leg or they tell you the hypotenuse. If they, in the first instance, they told us the leg. So we were solving for the hypotenuse. If the leg is 9, then the hypotenuse is 9 times the square root of 2. Okay? But now they're telling us that the hypotenuse is 6. So we're going to substitute 6 equals, let's give this a variable name, let's call it x. So it's going to be the square root of 2 times x. What's the matter? I haven't done anything yet. All I've done is write down the equation. Alan. All I've done is write down the equation and substituted what I know, which is that the hypotenuse is 6. I actually haven't done any math yet. Okay, now, how do we solve for x? How do we solve this for x? Jack? No. Tell me how to solve this. Tell me what to divide by. Bill's not here. John, tell me what to divide by here to solve for x. Can you? No, not 2. What is this? It's the square root of 2. Just because it says square root of 2 doesn't change the way we do the problem. We're still going to divide both sides by the square root of 2. Now, you can put your calculator away. It's just going to cause you problems because that's not what we're looking for. You don't need a calculator to do this. Yeah. Okay, now, you have learned in Algebra 1 class how to solve this equation. You are not allowed to leave a square root sign in the denominator of a fraction. So what you have to do, you have to multiply both sides by whatever square root is in the denominator of your fraction. So what happens is, we get 6 times the square root of 2. And then when I multiply the square root of 2 times the square root of 2, it gives me the square root of 4, which is 2. I can then simplify this and do 6 divided by 2, which gives me 3 square root of 2. The answer to the question is, if the hypotenuse is 6, each of my sides is 3 square root of 2.
Is that the easiest one?
What do you mean? So they're all the same. All the same difficulty. Okay, does anybody have any questions about this?
Yes, I do.
Okay.
How did you get 2 on the bottom again?
When I multiply the square root of 2, this you can put in your calculator if you want. If you multiply the square root of 2, Tiara, times the square root of 2, it gives you the square root of 4. And the square root of 4 is 2.
Alright.
Okay, questions? Other questions? Okay.